All right, today we're going to tackle a huge one, a question that scientists have been wrestling with for centuries. What is light, really?
I mean, it sounds simple, right? Is it a wave or is it a particle? But this one little question kicked off one of the biggest, most fascinating debates in the history of science. For hundreds of years, the answer just kept flipping back and forth. Every time someone thought they had it figured out, a new discovery would come along and just muddy the waters all over again.
So to really get a handle on this, we've got to go way back. I'm talking about the very first ideas, the first attempts to figure this stuff out.
Way back in ancient Greece, you had philosophers who thought our eyes actually shot out little rays, kind of like laser beams, to see things. It's called the emission theory. And yeah, it sounds pretty wild to us now, but hey, it was a real attempt to explain how we see. And at the same time, people were noticing other things, like how light always travels in a straight line, how it bounces off mirrors. The first pieces of the puzzle were starting to fall into place.
Okay, now let's jump forward. The 17th century is where things really heat up. This is where the real fight begins, a proper scientific showdown between two absolute giants of the time.
In one corner, you've got the heavyweight champion himself, Sir Isaac Newton. You've probably heard of his famous prism experiment, right? He took a simple piece of glass, shot a beam of sunlight through it, and bam, a rainbow. He proved that white light is actually made up of all the colors mixed together. And this incredible discovery led him to a pretty bold idea about what light is.
So, Newton's theory? He said light is made of teeny tiny particles, which he called corpuscles, just a stream of them flying through space. But in the other corner, you have Christian Huygens, and he had a completely different idea. He said, no, light is a wave, like the ripples you see when you drop a stone in a pond. So there you have it, particle versus wave. This was the big question, and it stumped scientists for the next 2 centuries.
For a long time, Newton's side was kind of winning, mostly because, well, he was Newton. His reputation was just massive. But then we get to the 19th century, and an experiment comes along that just seems to blow the particle theory right out of the water. It looked like a total knockout victory for Team Wave. And this is the famous double-slit experiment from Thomas Young. Here's how it works. You shine a beam of light at a screen with 2 very thin slits in it. Now, if light were just particles, like tiny paintballs, you'd expect to see 2 bright lines on the wall behind it, right? But that is not what he saw. Instead, he got this weird pattern of multiple light and dark stripes. This is called an interference pattern, and it's something only waves do. See, as the waves pass through the slits, they spread out and interfere with each other. Where 2 wave crests meet, you get a bright spot. Where a crest meets a trough, they cancel out and you get a dark spot. Little particles just wouldn't do that. No way.
So, the conclusion seemed totally obvious. That striped pattern could only happen if light was a wave. Case closed, right? For pretty much everyone in the scientific world, that was it. The debate was over. Light is a wave. Done.
And if that wasn't enough, the nail in the coffin seemed to come from James Clerk Maxwell. He came up with these incredible equations that proved light is actually an electromagnetic wave. He connected light, electricity, and magnetism all into one beautiful unified theory. I mean, it was a massive achievement, one of the biggest wins for physics in that entire century.
So that's it then. Story over. Or was it? Science has a funny way of throwing a wrench in the works just when you think you've got it all figured out. Just when the book was slammed shut, a really bizarre new discovery popped up, something the wave theory had absolutely no explanation for. It's called the photoelectric effect. And it goes like this. If you shine a light on a piece of metal, sometimes it can knock electrons off the surface. Now, here's the weird part. The wave theory would suggest that any color of light should work, as long as it's bright enough. You just keep blasting it with a bright light, and eventually, enough energy should build up to pop an electron loose. But that's not what happened. It turned out only certain colors of light worked. You could shine a super intense, blindingly bright red light on it for hours and nothing. But then a very faint violet light would knock electrons off instantly. The wave theory just couldn't make sense of that at all.
And then along comes Albert Einstein in 1905. He publishes this paper that completely turns everything on its head. He said, look, this whole photoelectric thing makes perfect sense if you stop thinking of light as a wave and start thinking of it as a bunch of individual little energy bullets. And just like that, in a crazy plot twist, Newton's particle theory was back from the dead.
Einstein was actually building on an idea from another physicist, Max Planck, who had suggested that energy comes in these little chunks, or quanta. Einstein just took it one step further and said, hey, maybe light is these little chunks. These days we call these packets of light photons. So, wait a minute. Was Newton right this whole time? What on earth is going on here?
So let's recap. We've got undeniable proof that light acts like a wave, and we have undeniable proof that it acts like a particle. How can it be both? The answer to this totally impossible puzzle turned out to be weirder and more wonderful than anyone could have guessed.
Get ready for this, 'cause it's a bit of a mind-bender. The answer isn't wave or particle. It's both. It's a wave and a particle. This is the idea of wave-particle duality, and it's one of the absolute pillars of quantum mechanics. Basically, light acts like a wave when it's just traveling along, but the moment it hits something, it acts like a particle. The crazy part? Which one you see really just depends on what kind of experiment you're doing to look at it.
And look, this isn't just some weird, abstract thought experiment. This is the real-deal physics that powers our world. The laser in a Blu-ray player? That uses light's wave properties. Fiber optic cables? Waves. But solar panels? They work because of the photoelectric effect. That's the particle side. The digital camera in your smartphone totally relies on light being a particle. So that amazing piece of tech in your pocket is literally a product of this bizarre quantum truth.
So, the story of what light is, it's really a story about science itself. It's a journey from things that seem obvious to a reality that is just strange and amazing. It just goes to show you that the universe is so much weirder than we can imagine. And it leaves you with a pretty big question, doesn't it? If something as basic as light can be two completely different things at once, what else out there do we think we understand but actually have no clue about?